Hi guys, thank you so much for joining this session. I'm Vivek, and I'll be bringing on a couple of series of machine learning techniques, basically. So today's session is based upon simple linear regression and how to implement that in a machine learning model. So I'll start off by the intuition behind the machine learning. The simple linear regression basically in machine learning. How is it implemented and what is the mathematics hidden behind it? So just to start, you can see I have this particular data set. It has two columns and basically 30 rows with the data, and the columns here represent the years of experience in a particular organization XYZ and the salary associated with the people that are working in that organization. So let's say the if a particular person has 1.1 year of experience, he has a salary of 39,343 and so on. So, what is first of all simple linear regression, and what are we predicting here? So, in let's say as a machine learning engineer, someone comes to you and says that, dude, I have this particular test data set. Based on that, I prepare a model so that when I give you, like let's say a person comes with 12 years of experience, what should his expected salary be? So, I want to just predict that. So, how will you approach it? So what is the the intuition behind a simple linear regression? First of all, I'll start with that. So let's start from very basic. Let's say you want to plot this on a particular graph. How will you plot it? So you'll start off by taking an x-axis and a y-axis. All right, so let's say you take an x-axis here, sorry, y-axis here, and then again an x-axis here. All right. Right, and this particular y-axis represents nothing but your salary. All right, and this particular x-axis represents nothing but your particular experience. I'm sorry, experience. All right, let's delete this. Okay, so just for an example, how would you plot this data? For a particular experience of a person, he would be having some kind of salary, right? So if you observe carefully, I have sorted this data in increasing order. So as the years of experience are increasing, the salary of the people are also increasing. Not in a totally linear fashion, but somewhat in a linear fashion. So if you try to plot this data, you know, if you try to plot this data, you'll get somewhat like some points are here, some 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 points are here, some points here, some points here, some points here, some maybe outliers, some might be like CEO or some kind of person. His experience maybe you know if it is a very uh, adult CEO, not very old, then his salary might be very high, and some points here, some points here. So somewhat in a linear fashion the data would be there, but not entirely what would we say, entirely linear data will be there. So if you plot it, so you can see the data will be somewhat like this. All right, so what we do in simple linear regression is we try to propose a line which is the best fit with this data. Now before I go ahead with best fit, I'll just give the formula for simple linear regression. All right, so it's nothing but y equals to b naught plus b1 x. All right, so what is what, I'll explain you properly. So first of all, what is y, then what is x, and what is let's say b1 and what is B naught. So we have four portions here. What is what, I'll explain you. So y is nothing but your y is nothing but your dependent variable. All right. X is nothing but your independent variable. Independent variable. B naught is a constant. All right. B1x is something which relates the relation between y and x. How, since you can see here they are not directly proportional, like if x increases, y also increases, they are not some directly proportional. B1 represents here the relation between how y and x are related. So it's also a constant and links x and y. All right. So as I said before, I I gave a term, that is the best fit line. What does a best fit line mean actually? So let's say I'll magnify this particular part, this plotted part. All right. So what this plotted part? So what does a best fit line mean actually? So I'll just draw this line. Let's say this red line is this line, and as I said, I had plotted these points, right? These points, somewhat, some might be on this particular line, some might be here, some might be here, some might be here, some might be here. So what does the best fit line mean? Best fit line is nothing but the sum of which minimizes the sum of the distance between the points and the line. Let's say that my distance here is 1, this is 1, this is 1, this is 2 somewhat, this is also 2, this is 4, this is 6, this is 4 again. So what a linear regression best fit line, what we do is we plot multiple lines. Let's say this one, this one, this one, and calculate, sorry for this line, this is not straight, but consider it a straight line. Let's say I'll plot this line, this, like in a line again like this. So what we'll do is we'll calculate the distance, square of the distances, and sum it. Let's say here 1 2 3 4. So somewhat for this line the square of the distances comes out to be 4. Well, all right, it comes out to be 4, and for this particular it comes out to be 6, and 6, and for this particular line it comes out to be 3. So our approach here is to minimize the sum of these squares basically. So we'll choose this particular line, it's the best fit line. It will be our prediction model basically, prediction line basically. So this is what the simple linear regression uh, gives us. So first of all, a very major point is in simple linear regression we have one dependent variable and only one feature. So how do we actually implement this into our Python code? So I okay I'll start off by, so this I myself use this spider notebook editor, and you are free to use whatever editor you are comfortable with. We have Jupyter notebooks, we have PyCharm, so whatever you want to use you can use, and I'll use this particular data set. So we start off with importing the required libraries which we'll be using going forward. So we'll be playing with NumPy, Pandas, Matplotlib. NumPy is basically used to manage all kind of numerical applications. Whatever numerical features we want, that is handled by NumPy. Then Pandas is used to handle your data set, and Matplotlib is used to plot the data on graph. So import NumPy as np. All right. Then we have import Matplotlib, import Matplotlib. dot py plot as plt. Then we have import pandas as pd. Right, I'll remove this comment part. So we'll import these mat matplotlib. Right. So see, these are imported. Now if you're using spider node, this spider editor, you need to set this particular dataset folder wherever your data set is located as your console working directory. You can do this by going here and clicking on set console working directory. You need to save this particular file of yours where you are writing the code in the same directory, right? Then it will be setting the console working directory. Now we need to import the dataset. Import the dataset. All right, so we'll take a dataset variable is equal to, then we use pd dot read csv, then we'll provide our csv name. If you go ahead and see the variable file explorer, it's salary underscore data dot csv, salary underscore data dot csv. All right, so just for precaution, go and hit control enter. See, it is successfully imported. Go in variable explorer, you can see that this particular data set is showing here. So in pandas, if as you know, in Python, the index starts from 0. We have a total 30 of rows until 29 index with years of experience and salary. All right, so now we'll define the x which is our feature, and y the dependent variable. Okay, so what we'll do is I'll take capital X data set dot iloc. Iloc is the parameter which we use to locate our particular columns. So here this is a major part, please. So how do you segregate the features and the dependent variables and the dependent variables? Basically, this iloc contains two parameters basically. Starting, let me give it in this way. So the parameter before the comma, it gives the rows, represents rows, and the parameter after the comma represents column. So here you can define the range. Let's say if you give 2 to 5, so it will take all the rows between 2 and 4. 5 is not included. All right, so since I want all the rows, I'll just do colon. It will consider all the rows, and here which a column, x is the first column, right? This one, the 0th index. So what I'll do is I can give it 0th index, or I can do it like this, -1. It will include everything except the last row. All right, dot values will do. All right, then we similarly do for y. Then we similarly do for y. Here only difference is we need everything same, but we need the last row. So we'll do 1. Now we'll do it y. All right, so here see, the x and y are imported, x and y, which represent the years of experience and the salary. All right, now we'll go ahead and do the training and testing data split. Why do we do a split? Basically because, and see, whenever you train a model, basically you have to test it. You cannot directly implement it or put it into production to run. You need to test how my model is performing and what kind of prediction it is doing, how good the prediction is. So for this, you have only this particular data, right? You have no other data apart from this. So you cannot train your model on all of this data. Then if you are providing anything, you'll have nothing to test your data on. So what we do is we take a amount of data from this as a training data, and amount of data, a small amount of data as a testing data. So generally, in a production scenario, the ratio is around 70 to 30. 70 is for training and 30 is for testing. We provide a huge chunk of data for training purpose so that our model trains perfectly. All right. So we'll do the splitting here. Splitting into training and testing. All right. So how we do it? We use the scikit-learn package. Scikit-learn is an industrial level, trademark, or you can say the accepted library for machine learning. Basically, you'll find a lot of applications of scikit-learn if you move into machine learning. Here we have linear regression, multinomial regression. We have everything, the machine learning related models already into scikit-learn. So it's sklearn dot model selection. Model selection. We need to import which package? The train underscore test split. All right. So now here comes the main part. Here you need to define your x train, comma x test, comma y train, comma y underscore test. These are the variables. All right. Then you'll do train test split. Now what the arguments it takes is what data first of all you need to split. These are the x comma y. All right. Then the argument is what is the ratio of the data which you want to. So we have the test underscore size parameter. All right. Here we give let's say 1/3 of the data we need to keep as test, and then we have the random state variable. Random underscore state, which is 0. What is random state? Basically random state is something like let's say I'm doing this particular split, right? So what happens is my data gets splits randomly. It's not like the first 30 will go into training and the last 1/3 will go into testing. It randomly picks data. That some data it will take into randomly into training and some random data into testing. So what in my code, if I run this code, the data which is being selected might be different from the data which in the code which you are running. There it is getting selected. So to give away that random part, we give random state as 0. All right. So random state 0 means for me and you the data will be same. All right. Then it comes the main part. Here we fit and apply the linear regression, fitting data for linear regression. All right, from scikit-learn dot linear model, import linear regression. Import linear regression. We have a regressor object there. We create a regressor object. Linear regression we pass into this. Linear regression. So now regressor object has the capability of linear regression basically. Then we fit our data into it. Regressor dot fit x train and y train. X underscore train x underscore train comma y underscore train. Okay. Now we'll run this part. I guess we have done the splitting, right? No, splitting part is not also done. So we'll first split the data. See, splitting the x test, x train, y test, y train. If you look into this, the training data is more as compared to the testing data. All right. So now we'll run this part. See, the regressor object has fit the data. Now we'll do our prediction. Doing the prediction basically here. Okay, and y underscore red will be regressor dot predict x test, x underscore test. So we need to predict the values for the testing data, right? Now, if you look into the variables, the predicted value, the y test here, and the predicted value. See, the values which it has predicted is somewhat near, not totally okay, but it is somewhat near. All right. So this is how it is done. The prediction part is how it is done. Now your regressor object has the capability to predict a particular single value or a set of if you pass the years into it, it will give you the prediction for the salary. So yeah, and what if you want to visualize this data? Visualization. This is also major part in your machine learning journey. It plays a major role. You need to visualize the data. How will you see it? And these numbers mean, I mean, it may mean everything to you, but for the stakeholder, these numbers mean nothing. If you want to show them your output, your data, you need to visualize it. All right. So how will you do it? We use the matplotlib basically. So we have plt dot scatterplot we are doing. All right. Xtrain will first plot the will visualize the training data. Train comma y underscore train comma color is equal to red. All right. Then we will do plt dot plot. Plt dot plot. We need to plot it, right? X underscore train comma regressor dot predict for values train color comma red call co color will give a different color here. We'll give blue. Right. Then we have the plt dot title salary versus experience. Give it this salary versus experience. This is the training set. Training set we are doing it right. See. And the x label and the y label we need to give plt dot x label. What is the x label here? The years of experience is the x label. Years of experience. Right, and similarly the y label we need to give the salary. Now we'll do plt dot show. All right. So if we do this, see, this is the plotting. This is the best fit line which is it is showing, right? So here you can see it, for it in the backend it would have tried multiple lines and tried to minimize the square of the distances basically, and this one was the line with the minimum sum. And what if I want to visualize the test set results? This is for train set, right? Visualize train set, and similarly you can do it for test set. Nothing would change, only the heading will be changing. So here we'll be doing the same thing, everything will be same. We'll be doing test set and the parameters will change. Xtrain regressor dot predict strain color. This will be x underscore test and this will become y underscore test. All right, the color will become red and everything will be same now. So visualize this particular data. Here it comes out for the test set. So this is how we perform simple linear regression into machine learning, guys. So if you have any doubt, you can go ahead and ask me in the comment section. Going forward, I'll be coming up with other methodologies in machine learning. Thank you so much.